India's lunar exploration program, Chandrayaan, has already achieved incredible things. Chandrayaan-1 launched in 2008, making India the fourth nation to reach the moon. Chandrayaan-2, in 2019, attempted a soft landing on the South Pole but unfortunately faced some challenges. Learning from Chandrayaan-2, Chandrayaan-4 is an even more advanced mission. Here's the exciting part. It's a two-part mission. Chandrayaan-4 will be launched in two parts using two different rockets. The first launch will use the powerful LVM-3 lifter to carry the propulsion module, the descender module, and the ascender module together. This combined unit will travel for several days until it reaches lunar orbit. Here, the propulsion module will be jettisoned, and the descender module with the ascender module on top will prepare for the descent to the lunar surface. The critical separation maneuver occurs. The pyrotechnic devices separating the descender module from the propulsion module are carefully fired, and the descender module with the ascender module on top begins its descent towards the lunar surface. The descent is a precisely controlled process using the onboard thrusters to slow down the descent module and reduce its velocity to a safe landing speed as it approaches the lunar surface. During the descent, the lander uses its onboard sensors and cameras to analyze the lunar terrain and identify a safe and suitable landing location. It may even make small course corrections using its thrusters to ensure a smooth touchdown on the lunar surface. The descender module touches down on the lunar surface, its landing gear absorbing the impact and coming to a rest. Once the dust settles and all systems confirm a stable landing, the mission enters the sample collection phase. The robotic arm, which has been stowed securely during landing, carefully extends out towards the lunar surface. The arm is equipped with specialized tools and mechanisms designed to gather lunar samples. These tools may include a coring drill to extract samples from beneath the surface, scoops to collect loose regolith, or scrapers to gather material from specific rock formations. The exact type of sample collection will depend on the scientific goals of the mission and the specific characteristics of the landing site. The control room team on Earth will carefully monitor the arm's operation and send commands to precisely position it for sample collection. The collected samples will be stored in a special container within the descender module, which is designed to maintain their integrity and protect them from the harsh lunar environment. Once the sample collection process is complete, the robotic arm carefully places the samples into a sealed container designed for the ascent to lunar orbit. This container may be equipped with a temperature control system to maintain the samples at a desired temperature range during the transfer and storage. The transfer mechanism between the descender and ascender modules may involve a conveyor belt system or a direct docking port, depending on the specific design of the spacecraft. Once the samples are securely transferred, the transfer compartment is sealed, and the ascender module prepares for liftoff from the lunar surface. The ascender module, now carrying the precious lunar samples, initiates its liftoff sequence. The lunar lander's ascent engine ignites, with the powerful thrust shaking the module momentarily. As the engine roars to life, the ascender slowly lifts off from the lunar surface, leaving behind the descender module that served its purpose. The ascent module steadily accelerates, climbing higher and higher above the lunar surface. Using its onboard navigation system, the ascender module carefully adjusts its trajectory to achieve the precise orbit needed to rendezvous with the transfer module, which is already circling the moon. The journey to lunar orbit takes time, and the ascender module's thrusters may fire periodically to make minor course corrections or adjust its speed. Throughout the ascent, the engineers at the ISRO Mission Control Center in Bangalore keep a watchful eye on the telemetry data streaming from the ascender module, monitoring its systems and performance. The transfer module transfers the samples to the reentry module. The reentry module separates and returns to Earth, bringing back the lunar bounty for further analysis. What are you most excited about with Chandrayaan-4? Let us know in the comments below. Don't forget to like and subscribe for more space exploration content.